Hi, I'm going to show with this example why some of the methods do not work or why they work but it's very difficult. So I'm sure many of you seen this problem in class, and if your first intuition is I'm going to try integral test. Let's see what happens if I do integral test. Firstly, you will know, this is a good function to choose for my integral test. And then in order to integrate something like that, I need to factor the denominator completely, which is the first obstacle that most of you will have. Most of you probably will not know that this is a factor of x cubed minus 8. Even if you know that the next step is, oops, I made a little mistake. It should be 2x here. It should be 2x there. But you know the next step is partial fraction. So now I have to find a, b, and c. Okay, let's just suppose that you're very smart and you can find a, b, and c very quickly. It's 1 over 12, negative 1 over 12, and 4 over 12, negative 4 over 12. And then you still have the next difficult step of finding the improper integral. All right, I can integrate this very quickly, but can you integrate this very quickly? You know it requires completing the square. And so you see this step using the integral test is pretty difficult unless you are very, very quick in partial fraction, finding out the constants, and integrating something like that. All right, then what about if I try DCT? Isn't it a good choice too? Now you know what it takes to do DCT. It needs a Bn. There's a very obvious Bn is 1 over n cubed. But unfortunately, if that were an, 1 over n cubed minus 8, the bottom being smaller, is bigger than 1 over n cubed. So you have an inequality that says an is bigger than bn. And you know that bn being a p-series is converging. So this is not DCT1 and this is not DCT2 too. So again, you fail. So let me repeat, why does DCT not work? Because DCT requires that AN is smaller than BN. Why is DCT2 not working? Because DCT2 requires that this diverges, but yours is converging. So that doesn't work. It is true that some very, very smart students can get around with DCT, but the very smart student will say, I'm going to try BN that is 1 over a smaller power. A smaller power like 2.5 or 2. But then how do you establish this? You got to be really, really good. So again, DCT is not possible using this BN, and with this BN, you will never be able to establish that inequality. So if you try DCT, you got to be really, really, really good. Did I hear somebody say NTDT? When you're really going on off wrong track. Why doesn't that work? You can see that this thing is obviously 0. And that's why NTDT don't work. And don't tell me that because the limit is 0, the series is converging, because that it's a wrong way of doing series. Never ever say limit 0, series convergent. So never ever say this. Some students say, oh, you know something, maybe that is a telescoping series. No, it's not a telescoping. It is true. You can write this as a difference of two things. The first thing being 1 over 12 of n minus 2, and the other one being 1 over 12 n plus 4 over 12 over n squared plus 2n plus 4. Whew, this is quite a lot to say, but this is definitely not a telescoping series. It doesn't telescope like what you think it will. So if you're thinking that, oh, a telescope, no, that doesn't work. So the fastest and easiest way to do this is the limit comparison test. So go ahead and do limit comparison test. I assure you it will work. So I'm going to stop here now.